Scene script. Have you ever wondered how space exploration might change with the advent of 3D printing technology? Welcome to a fascinating journey where we'll uncover how the dawn of a new era in space exploration is being propelled by an innovative leap, 3D printing. The cosmos has always been a realm of mystery and grandeur, a vast expanse that has intrigued us for generations. Since time immemorial, we've gazed at the stars, moon, and galaxies far beyond, with a yearning to explore and understand. Space exploration, as we know it, is a testament to human ingenuity and technological advancements. It's a field that's always evolving, always pushing the boundaries of what we think is possible. And one of the key elements fueling this relentless pursuit of the unknown? Rocket engines. Rocket engines, these marvels of engineering, are the heart of every spacecraft. They are the workhorses that ferry our astronauts and satellites through the harsh void of space. They are the powerhouses that defy gravity, speed through the cosmos, and help us reach destinations beyond our earthly realms. But as we venture deeper into the universe, our needs and challenges grow. The traditional methods of constructing rocket engines, while effective, are time-consuming, costly, and often limit our ability to innovate and adapt quickly. Enter 3D printing, a technology that's revolutionizing not just how we create, but also what we can create. 3D printing, or additive manufacturing as it's technically known, has the potential to transform space exploration as we know it. It's a technology that can build complex structures layer by layer, with immense precision and efficiency, and when applied to rocket engines, the possibilities are truly astronomical. Imagine designing and printing a rocket engine that's lighter, more efficient, and quicker to produce than anything we've had before. Imagine the strides we could make in space exploration, the new frontiers we could reach, and the cosmic secrets we could unveil. That's the promise of 3D printed rocket engines. So how does the 3D printing of a rocket engine work? Let's dive deeper. Before we venture into the specifics of the rocket engine, it's crucial to understand 3D printing technology. So, what is 3D printing? It's a process that creates a three-dimensional object from a digital design. You can think of it as a symphony of precision, where thin layers of material such as metal or plastic are meticulously placed one on top of the other until the object takes shape. This technology, also known as additive manufacturing, is in stark contrast to traditional methods that often involve cutting or drilling away material. With 3D printing, we only use what we need, which reduces waste and can save resources. Now, you might be wondering, where is 3D printing used? Well, it's used in a myriad of industries. From creating intricate jewelry designs to constructing entire buildings, it has revolutionized the way we manufacture. In the medical field, it's used to create custom prosthetics and even organs for transplant. But for our discussion, the most exciting application of 3D printing lies in the aerospace industry. Here, it's used to create complex parts that would otherwise be difficult or impossible to manufacture. It allows for lighter, stronger components and rapid prototyping, which are key in an industry where every gram and every second counts. Moreover, 3D printing can potentially minimize the cost and time of production, making space exploration more accessible and feasible. It's like having a mini factory that can produce almost anything you need, when you need it. However, 3D printing is not without its challenges. It requires advanced design skills and understanding of materials. The process can be slow for larger objects, and there are limitations to the types of materials that can be used. But despite these hurdles, the potential benefits far outweigh the drawbacks. Now that we understand 3D printing, imagine the possibilities it opens up in the realm of space exploration. The concept of a 3D printed rocket engine might sound like science fiction, but it's a reality NASA is bringing to life. The magic of 3D printing has now extended its reach into the infinite cosmos, revolutionizing the way we explore space. Let's take a closer look at this fascinating innovation, NASA's 3D printed rotating detonation rocket engine. This isn't just any rocket engine, it's one that's been carefully crafted layer by layer, using the marvel of 3D printing technology. But what makes it so unique? Well, it's all in the name. This engine operates on a process called rotating detonation, an approach that's vastly different from traditional rocket engines. In most rocket engines, combustion occurs in a steady, controlled manner, but in a rotating detonation engine, the combustion process is anything but steady. It's explosive, it's powerful, and it's incredibly efficient. The engine utilizes a series of controlled explosions that travel around a circular channel, providing the thrust needed to propel the spacecraft. What's more, the 3D printing process allows for intricate designs and complex geometries that would be near impossible with traditional manufacturing methods. This means NASA can create more efficient, more powerful engines, all while significantly reducing the cost and time needed for production. The 3D printed rotating detonation engine is a testament to human ingenuity and the limitless potential of 3D printing. It's a game changer, a boundary pusher. It's a lighthouse guiding us towards a future where space exploration becomes more accessible, more feasible, and more sustainable. But let's not get ahead of ourselves. We've only just scratched the surface of this remarkable innovation. Intriguing, isn't it? But how does this 3D printed rocket engine function? Stay tuned as we delve deeper into the mechanics of this extraordinary piece of technology. The functioning of a 3D printed rocket engine is a complex yet fascinating process. It's a symphony of science, technology, and engineering, all coming together to create a powerhouse capable of propelling us into the cosmos. Let's delve into this intricate process. At the heart of the 3D printed rocket engine is the combustion chamber. This is where the magic happens. Fuel and oxidizer are injected into the chamber, where they mix and ignite. This combustion process creates a high-pressure, high-temperature environment within the chamber. Now you might be wondering, how does this result in the rocket's movement? Well, it's all about the principle of action and reaction, famously described by Sir Isaac Newton's third law. The intense pressure created in the combustion chamber needs an outlet. This outlet is provided by the rocket's nozzle, a carefully designed structure that channels the combustion gases out in one direction. As these gases rush out of the nozzle at high speed, they create an equal and opposite force that propels the rocket in the other direction. This is what we call thrust. The more efficient the combustion process, the greater the thrust generated, and the faster the rocket can travel. The beauty of a 3D printed rocket engine lies in its precision. The intricate details that can be achieved with 3D printing technology allow for more efficient fuel combustion and consequently greater thrust. Furthermore, the ability to produce complex geometries and structures that would be challenging, if not impossible, with traditional manufacturing techniques gives 3D printed engines an edge in terms of performance and reliability. With every rotation of this engine, we're witnessing a marvel of modern technology. It's a testament to human innovation and our relentless pursuit of knowledge and exploration. This technology is not just about creating a rocket engine, it's about transforming space exploration. Each ignition, each burst of thrust, brings us one step closer to unlocking the mysteries of the universe, and that, my friends, is the true power of a 3D printed rocket engine. The 3D printed rotating detonation rocket engine is a game changer for the future of space exploration. This technology has made an indelible mark on the way we venture into the cosmos. The impact of 3D printed rocket engines is far-reaching, and it's worth delving into the substantial benefits they bring to the table. Firstly, cost efficiency. Traditional manufacturing techniques for rocket engines are expensive, time-consuming, and labor-intensive. On the other hand, 3D printing, also known as additive manufacturing, allows intricate parts to be created with significantly less material waste. This results in a drastic reduction in costs, making space exploration more accessible and financially viable. Secondly, the speed of production is revolutionized. What once took months or even years to construct can now be produced in a matter of days or weeks. This faster production time not only accelerates the pace of technological development but also enables rapid iteration and improvement of engine designs. Lastly, the potential for deep space exploration. The ability to print rocket engines in space could be a game changer. Imagine a future where spacecraft don't need to carry all their fuel and spare parts from Earth. Instead, they could print what they need, when they need it, using materials found in space. This could potentially extend the reach of our exploratory missions, opening the door to the farthest corners of our universe. Looking ahead, the prospects of this technology are tantalizing. As 3D printing techniques continue to evolve, we can expect to see more complex and efficient designs, smaller and lighter engines, and ultimately, more ambitious space missions. Perhaps we'll even see the day when entire spacecraft are 3D printed. The future is exciting, and the 3D printed rocket engine is at the forefront of this new era in space exploration. It's not just about reaching the stars anymore, it's about understanding them, living among them, and harnessing their resources. Indeed, The 3D printed rocket engine is a giant leap for mankind, taking us one step closer to the stars.